In this code review, I will analyze and enhance a defect analysis system. This artifact, originally created in Excel, tracks defect trends in manufacturing. The goal is to mitigate this data into a scalable database, optimize query performance, and enable real-time defect analysis. Currently, defect data is stored in Excel spreadsheets divided into multiple sheets based on defect type, occurrence date, and description. While this approach provides structured data, it has several limitations. Data retrieval is slow and requires manual updates. No real-time querying or filtering capabilities exist. Inconsistent column formatting makes data processing difficult. The Excel file contains multiple sheets, including defect data categorized by type, month, and problem breakdown. I will now examine a few key sheets, such as machine products DMRs, DMR by defect type, and defect type by month, to understand their structure. Here's an overview of the three key sheets. The machine products DMRs, we have the DMR number, we have the subject, which is the defect type. We also have the description of the defect, the date it was submitted, closed, and the month it was opened and closed. So this sheet stores defect material reports and provides a detailed defect log, but is currently stored statically in Excel. Next, DMR by defect type. This sheet aggregates defect descriptions by type. Some data appears misaligned. Column headers are not properly structured. To further explain the DMR by defect type sheet, this was key in our problem breakdown of the many defect types that occur over the last 2 years, and using each defect type, for example, threaded insert failure or stains and discoloration, is not enough to describe the issue. The description is better for analyzing our defects in manufacturing. The description holds more information, such as how many parts failed. For example, 11 parts failed this sample size, and 3 parts failed for poor plating uniformity. Also, in one DMR, there can be multiple defect types. So on the left column is me categorizing each individual DMR by how many defect types each description contains. As you can see, this one contains multiple, several in fact. First, we did not receive first article paperwork. We did not receive material and finish certs. 5 parts contain debris lodged in a threaded hole. The threads are non-uniform. And all parts fail the go-no-go gauges. That is just one example. Each of these is a different category of defect type to further break down our problem. And the numbers, the color helps categorize for the defect type as well. So as you can see, everything under documentation issue was categorized as a documentation issue defect, but the orange represents DMRs that also include dimensional issues as well. such as failing length, width, and height, or failing thickness, etc. And then the ones in yellow are DMRs that were categorized as other defect types but contain documentation issues as well. As you can see, there are several. So the current system does not give us all the information we need to break down the problem and analyze our defects over a certain amount of time. And this was really tedious, going through 192 DMRs to get down to the nitty-gritty. Next, defect type by month. It contains a time series breakdown of defects by month. It's useful for trend analysis but currently lacks database-backed querying. So this table I pulled from our data. A static Excel sheet was converted into a table, and this is over the last 2 years. And you can see the types of defects that occur over the last 2 years by a month, and which ones are the most persistent. As you can see, blue and dark green are the most persistent each month over the last 2 years, which are dimensional failure and documentation issues. So those are the ones we would tackle first. And this is just focused on documentation issues over the last 2 years. As you can see, this is our highest number, 13. That is the functionality of my Excel sheet. Now I'm going to analyze the Excel sheet using the checklist provided. I'll critically evaluate the database design, data processing approach, and migration strategy based on the Excel data. For the structure, the Excel sheets are logically categorized by defect type, time period, and detailed reports. The machine products DMRs sheet acts as a defect log, which can be directly converted into a database table. Areas for improvement, the DMR by defect type, right here, sheet has inconsistent column names and missing headers, which will need data cleaning before migration. Redundant columns, for example, duplicate DMR number column should be removed before import. For the purpose of this code review, I have hidden the redundant column I was describing. For my enhancement plan, I'm going to clean and pre-process the data before storing it in MongoDB or SQL. Also, I will normalize the defect types into a separate table / document to avoid redundancy. Moving on to documentation. The Excel sheet needs more documentation since the data is currently stored in Excel. The logic behind defect categorization is not explicitly documented. There are no clear SQL schemas or JSON document structures defined for the migration. For the enhancement plan, I will clearly define a database schema before migration and add comments in the migration script to explain data transformations. Next, for variables, there are consistent date formats. The date fields, date submitted / date closed, are stored in year, month, date format, making them compatible with databases. However, there's inconsistent categorical data. Some defect descriptions contain special characters or inconsistent spellings. Also, column names such as plating, lifting, peeling metal have spaces and special characters which could cause query issues. For the enhancement plan, I will standardize the defect types before inserting them into the database. Also, I will replace special characters in column names with underscores for easier query handling. So there's no indexing in Excel. Queries on large data sets, for example, defects grouped by month/type, will be slow without indexing. For the enhancement plan, I will use indexes on DMR number, date submitted, and defect type to improve query efficiency in SQL/MongoDB. I'll also implement aggregation queries in MongoDB or MySQL to track defect trends efficiently. For defensive programming and error handling, there's currently no error handling in my approach. Since the data is manually entered, there is a risk of typos or missing values, and some records have empty or undefined values in defect descriptions. In my enhancement plan, I will use try except blocks in Python to handle missing or malformed data during migration. I will also implement constraints in SQL, such as not null or on critical fields, to prevent incomplete records. I want to note for automation and scalability, this is a manual process. The current Excel-based approach requires manual updates and does not allow for real-time defect tracking. For the enhancement plan, I will develop a Dash web application to replace static Excel charts, and I will automate defect reporting with scheduled database queries instead of manual Excel analysis. I will also generate automated reports summarizing high-risk defects. By implementing these enhancements, I will demonstrate database management by transitioning from Excel to a scalable solution, efficient query execution by using indexing and aggregation queries for real-time analysis. I will demonstrate data visualization and automation by building a Dash web base to replace static Excel reports. I will also demonstrate process optimization by eliminating manual tracking with automated defect reports. These improvements align with course outcomes related to designing computing solutions and using innovative techniques in data management. In summary, migrating defect data from Excel to a database will improve scalability, query efficiency, and automation. These enhancements will enable faster, more accurate defect analysis, benefiting quality control in manufacturing. Thank you for watching my code review. I look forward to implementing these improvements and demonstrating them in my final ePortfolio.